We are moving into chapter 7. Chapter 7, we're going to be talking about angles, triangles, those kinds of things. So we're going to start with adjacent and vertical angles today. So adjacent angles have two things in common. They share a side and a vertex. Something else you can think of is that they're next to each other. Another thing that I've thought of is when I think of adjacent, I hear the word joined in there. So adjacent means that they're joined. So if I had an angle like this, here's my angle, and now I have this middle section here. These angles are next to each other. They're joined, right? That's what I mean by adjacent angles. They're joined. So in this case, they share a common side right here and a common vertex right here. Okay? That's adjacent. I also have vertical angles. So vertical angles are opposite angles of intersecting lines. And I'm going to write this word congruent, and we're going to talk about it. So if I want to talk about vertical angles, they're opposite angles. So if I have these intersecting lines here like this, put these lines here, vertical angles happen across from each other. So here is one angle, here's its vertical angle. It's across from the other one. Okay? So adjacent means joined, vertical if you want to write across, maybe that would help you remember. Okay, I wrote that word congruent. So we also have what we call congruent angles. So congruent angles are angles with the same measure. And what I mean by same measure is they're the same degrees. Right, we talk about angles with degrees. So congruent angles are angles with the same measure, which means they're the same degree. Something to note about this then is that vertical angles are congruent. It's an important thing to remember. Vertical angles are congruent. Okay, that's all the vocab. So I have 4 different classifications of angles. I have acute angles, less than 90 degrees. Right angles are equal to 90. Obtuse are greater than 90 degrees and less than 180 degrees. And then straight angles, or a straight line, is equal to 180 degrees. Okay, so let's do some practice here. So first of all, when we're looking at naming angles, sometimes we can use just the letter itself to name angles, but that's not always super clear. And so if I want to use, if I want to identify angles, I need to use a 3-point system. So what I'm going to do is I'm going to look at, well, what's a point on one side? I want a vertex or a point on one side. What's the vertex of the angle? And then what's the point on the other side? So I'll show you what I mean. So if you look at this figure here, angle A is kind of just off by itself over here, right? Angle A is right here. It's kind of off on its own. And so it's pretty easy to see that angle A is where it is, right? But let's say I wanted to talk about this angle over here, and I just said angle D. Well, which one of those angles is angle D? It's a little bit hard to tell, right? So in this case, what it focused on is angle BDE. So the angle BDE is BDE, that angle right there. I wouldn't have been able to know that without this sort of method of doing it. So if we want to look and name the right angles, we'll just name a couple. So right angles, angle A is a right angle, because I know this is a square. Angle F is a right angle. Let's do one more. Let's find a better way to figure out angle D. So if I wanted to figure out what angle D is, angle CDE, CDE would be that angle. Obtuse angles. I have one obtuse angle, which might be kind of hard to see, but my one obtuse angle actually happens right here, ABE. Is that right? No, ABD. Right, so then I have angle ABD is my obtuse. Then if I'm looking for an acute angle, well, that angle BDE is acute. And let's do one more here. No, let's not do that one. Let's do EBD is also one. Right? These are some different angles that we have. Which angles are adjacent? Well, I have angle BDE, if I want to look at that one. What angle is right next to angle BDE? Well, the one right next to it is CDB. Right? And angle CBD. Let's find one more. If I want to look at, let's see, EBD, angle EBD would have an adjacent angle of CBD. Here's what I want you to notice about this, right? One of the things we said about adjacent angles is they share a side and they share a vertex. So if I look at these, oh, I must have done something wrong. BDE, CDB. I got those mixed up. CDB. There we go. Okay. I have the same vertex. Here's my vertex, the middle one. Same vertex. They're also going to share a side, right? I know that too. So it has B in common here, and it has D in common here. Shares a side, shares a vertex. All right. So now it wants us to name two pairs. We're just going to do one pair of each. One pair of adjacent angles and one pair of vertical angles. So if I want adjacent angles are next to each other. So I'm going to do angle VWX, and then if I have vertical angles, they're across from each other. So let's do VWZ and something else. So I'm picking the first angle for you to work with. I want you to find the next one. So tell me, what is an angle that's adjacent to VWX, and what is the angle that is vertical to VWZ? Go ahead and try that on your own. Okay, so if you're looking at VWX, you had two options of adjacent angles. You could have written angle VWZ or angle XWY. Either one of those would be adjacent. Now the vertical angle to VWZ, so what I'm looking at now is VWZ. There's only one option here. You should have had the angle of XWY. Okay, go ahead and do the second one on your own. And let's just move on to this next page. So you can do that one for practice. Okay, so let's look at these together. So first we need to decide whether the angles are vertical or adjacent, and then find the value of x. So if we remember, vertical angles are across, adjacent are joined. So if I look at letter A, these look like they're across from each other. So these are going to be vertical angles. And if you remember, what I know about vertical angles is that they're the same. So what that means is that x needs to equal 70 because they're the same. If I look at letter B, these two angles are connected, they're joined. So these are going to be adjacent angles. Okay, and this one may feel a little bit trickier, but here's what I know, right? These two angles come together and they form a specific kind of angle. And I know that by this box down here, which means it forms a 90-degree angle. So that means when I put those two together, it's going to equal 90. So 31 plus x plus 4 needs to equal 90 degrees. Well, if I'm going to solve, I'm going to combine what I can combine. So I would have x plus 35 equals 90. I could subtract 35 from both sides. That would leave me with x needs to equal 55. Okay? All right. This one is going to be a little bit hard to do virtually, but we'll do what we can. I wonder if I can get a protractor on here. Let's see. If I have a virtual protractor. Well, we can do this. Let's try this. Paste. No. Save image. Protractor. Here. Is it gonna work? Nice. Okay. All right. Here we go. So I'm going to use a protractor to draw a pair of vertical angles that measure 40 degrees. So here's what we got to do. So we need to start by drawing a straight line somewhere. So I'm just going to, let's move this up here like this. And I'm just going to draw a straight line here quick. So let's do it like, I don't know, right here. Drawing it as straight as I can. It's not going to be great. Straight line. Okay. So here's how we would do this. I have this protractor. I have my line. What I want to do is I want to line up the center of my protractor with the start of my line and make sure that it is even with everything else. What I want is I want a pair of vertical angles with a measure of 40 degrees. So I'm going to take my pen and I'm going to mark it at 40 degrees. Right here over at 40. So it's going to go right there. Move my protractor out of the way. And this is not going to be great because I don't have a straight edge like this, but we're going to connect those two lines. Not bad. Here is my 40-degree angle. Get in the habit of labeling these. It's going to be important as we do more things with angles. So that's my 40-degree angle. It tells me that I want to create a pair of vertical angles though. Vertical angles are across from each other. There's a real simple way of doing that. I'm just going to extend both of these lines. That means that this angle now is also 40 degrees. Okay, we'll do more practice with this later. But here's how we do that. Let's see. The rest of this is just going to be practice on your own. So you're going to do practice finding pairs of adjacent and vertical angles. finding the value of x, so that's the same thing that we just did. And then there's one problem on the bottom here, so just pay attention, this is a straight line down here. Straight angles are 180 degrees, and you need to fall to the left. So the tree is going to fall to the left. So go ahead and complete this practice on your own. I have the answers to these uploaded in Canvas, so you can check those there when you're done.